Welcome to Trigonometric Functions, Part 1. All right, question number 1. In a directional broadcast antenna, Tower 2 is located 212 feet from Tower 1. In a direction of 38 degrees north of east, how far to the north of Tower 1 is Tower 2 situated? So the first thing I like to do on these is draw a picture. So we know that we've got a direction of 38 degrees north of east. So we're going to go to the east and then go north. It's north of east. So that gives us the theta of 38 degrees there. And we know that the distance of the tower from Tower 1 to Tower 2 is 212 feet. So that's that purple line there. So now if we box everything up, we've got an angle. We've got 212 feet, and we've got an opposite and adjacent. The opposite of the angle, the opposite side from the angle, and the adjacent to or touching the angle. So now that we've got our drawing done, we know where the angle is, we know the distance, the 212, we've defined the 212 feet. We know which side is our opposite. We know which side is our adjacent in reference to theta. We need to review our formulas. So we see that sine of theta is equal to opposite over hypotenuse. Cosine of theta is equal to adjacent over hypotenuse. In tan of theta, or tangent of theta, is equal to opposite over adjacent. So we've got the opposite and the adjacent, so which one is the hypotenuse? The hypotenuse is the 212 feet. So now we know basically all of our sides of the triangle. We want to figure out what is the question asking for. So the question is asking for how far to the north of Tower 1 is Tower 2. So we can see from our drawing, we want to go north from Tower 1, and we see that we would want the opposite. We wouldn't want to use the sine of theta is equal to the opposite over hypotenuse. So now if we insert all of our known variables, we get sine of 38 degrees is equal to opposite over the hypotenuse, which is the 212 feet. So we can simplify that. So the opposite is equal to sine times 38 degrees times 212 feet, or sine of 38 degrees times 212 feet. Now make sure that you are in degrees in your calculator on this one. And we find that the opposite side of the triangle is equal to 130.52 feet. So now we can say Tower 2 is situated 130.52 feet north of Tower 1. Example question number 2. The broadcast antenna is 100 feet tall, and it is recommended that the guy wires to the top be anchored into the ground at an elevation angle to the horizon of 50 degrees. Find the length of each guy wire and the anchor point distance from the antenna base. All right, so we're going to start off with our drawing. Draw in our knowns. We know that the height of the antenna is 100 feet tall. We know that the angle that we're looking for is 50 degrees, how do they say it, up to the horizon. And so we're looking for the guy wire length is going to be the hypotenuse. And we can see that opposite of that angle is our height of our antenna. So that's the opposite. We've got that. That's 100 feet. And our adjacent is going to be the distance from the base of the antenna to where we're going to anchor these guy wires. So that's our adjacent. So we're going to review our SOHCAHTOA formulas and start figuring out which one goes to which. So if we look at the sine of theta is equal to opposite over hypotenuse, we've got an opposite and we've got an angle. So we can solve for the hypotenuse using that equation. And we know that the hypotenuse is going to be the length of the guy wire. So we should get the hypotenuse is equal to 100 feet divided by sine of 50 degrees. Now make sure again that your calculator's in degrees when you do this. The answer comes out to 130.541 feet. All right, so now we have the hypotenuse or the length of the guy wire. And the temptation might be to use the cosine function. The problem with that is you may compound, if you've got a mathematical error in your hypotenuse calculation, you're using that same hypotenuse to then calculate the distance of the anchor point, and it's just going to compound your errors. So in order to minimize any kind of compounded errors, I like to use my knowns that are given in the equation as much as possible. And so in that case, if we use the tangent formula, because we've got the opposite and we've got an angle, we could now solve for the adjacent. So we can see that the adjacent is going to be equal to the 100 feet divided by the tan of 50 degrees, which should give us the anchor point, or the distance from the anchor point or the antenna base to the anchor point of 83.91 feet. Example question number 3. A microphone diaphragm intercepts 6.75 nanowatts of acoustic power when broadside to the sound source. What will be the theoretical intercept power if the diaphragm is turned at an angle of 55 degrees to the source? So this one's a little bit tricky just to kind of think how what they're asking for. So the most power that you're ever going to have is when you're broadside. So when the acoustic waves are hitting the diaphragm or the microphone, it basically, if you think of it in this drawing, the hypotenuse is in purple. If the microphone was the x-axis, the hypotenuse would be tipped and would be coming straight in on the y-axis. So the most power you're ever going to have is when that x-axis is perpendicular to the source. Now this question is saying, okay, well, what would the power be if the source is still coming in the same way, but the microphone now gets tipped at 55 degrees? And so what this image right here is showing is we had a max power of 6.75 nanowatts when we were head on, but now when we tip, we're going to see that power go down. So on these types of questions, whenever you're broadside, that's your maximum power. That has to be your hypotenuse. So we're going to tip that 55 degrees, and now we can see that red line is the adjacent to the 55 degrees, And that's the theoretical intercept power that we'll be receiving at this point. All right, so because we want to solve for the adjacent, we know that when the microphone is perpendicular to the sound source or broadside, we're going to have our maximum power. We know in this case it's 6.75 nanowatts. And we know that that maximum power, broadside power, is always going to be the hypotenuse. So if we shift one way or the other, the perceived or theoretical power will always be less than the hypotenuse power or maximum power. So in this case, we're going to use cosine to solve for the adjacent. And if we do the math right, we should get a theoretical intercept power for the microphone when it's turned 55 degrees of 3.72 nanowatts.